An international team of scientists, including the University of Houston, has developed a new type of sodium-ion batteries that has the potential to become the new standard battery. The new material, sodium vanadium phosphate, gives the battery a higher energy density of 458 watt-hours per kilogram. That is 15% higher than the previous generation of batteries. Sodium vanadium phosphate is a super ionic conductor. It delivers a high continuous voltage of 3.7 volts and has a high electrode stability. Existing materials can only deliver 3.37 volts. This diagram shows electronic conductivity on the x-axis versus ionic conductivity on the y-axis. Sodium vanadium phosphate has a high ionic conductivity and a low activation energy for ion transport. In this diagram, it is in the red zone at the top. Lithium-ion batteries with the high energy density are the current standard. Lithium has less than 1/3 of the molar mass of sodium. The lithium-ion batteries have made long-range and efficient electric cars like the Tesla Model S possible. This is a comparison of different battery technologies and their costs. The sodium-ion battery at the left has advantages in abundance, economy, and environmental impact. The lithium-nickel-manganese-cobalt oxide NMC battery in the middle has the highest energy density, but is the most expensive battery. The lithium iron phosphate LFP battery at the right has a lower energy density than the NMC battery, but is cheaper because it does not contain the problematic chemical elements cobalt and nickel. The current price of lithium-ion batteries is at a record low of about $78 per kilowatt hour. This is an overview over the sodium-ion battery technology. All its components, the electrodes, the electrolyte, and the binder are the subject of current research. At low temperatures, the sodium-ion battery is known to perform better than the lithium-ion battery. BYD's electric bus has been constantly optimized. The Chinese company BYD has a hybrid battery pack of 2/3 sodium-ion plus 1/3 lithium-ion batteries. This combines the advantages of both technologies. Renewables, smart grids, and energy storage are key components of a fully sustainable system in the future. You can check out the links to the scientific articles in the description field. And you can check out my other videos from the chemistry series. Thank you for watching.